I will take that as a yes. Okay, well, welcome to today's seminar. Today we have Felermino Ali presenting, and he'll be talking about leveraging Loanword constraints for improving machine translation in low resource settings. So Felermino is a postdoc at Microsoft Research Africa here in Nairobi and a PhD candidate at the University of Porto in Portugal. His research focuses on NLP processing, particularly for low-resource African languages, with an emphasis on developing neural machine translation systems and improving methods for evaluating machine translation performance in these settings. And today he'll be talking about how you can translate between worlds when data is scarce and the language is full of twists. So thinking about loanwords, code switching, and orthographic quirks. He'll discuss how to apply lexicon-guided neural machine translation, integrate bilingual dictionaries and loanword mappings into the training process to address these challenges for Emakhuwa, I hope I pronounced that right, which is a low-resource Bantu language. This method suggests a promising direction for low-resource machine translation by bridging data scarcity and vocabulary gaps through structured lexical integration. And I believe Felermino presented this at EMNLP earlier this month, so we're super excited to have him. And over to you, Felermino.
Thank you, Stephen. First of all, I'm happy to be here. And can you please confirm if you can see my screen?
Yes, go ahead, let me know.
So, as Stephen mentioned, this is basically a paper that recently I've presented at EMLP, which is this one. And just to make the presentation more easy to follow, I will step back on the background of machine translation, and then I'll go through the paper and what was the idea behind it. So going back for the context of the whole paper, which is machine translation, which is the task of converting the meaning from one language into another by means of a machine, which we can see in this slide where we are trying to translate from Portuguese into Emakhuwa, the sentence like, can you speak and read Emakhuwa? So the translation is something that is there. So this is a machine translation task, which is something that has been around for a long time, and early machine translation system dated like in 1950s, and the first machine translation system at the time were based on rules, like rule-based system. It used to have like a lot of insights from linguistics. So these systems, basically, it was like something that we have in the right side of this slide, where you want to translate the word have, and then depending on, for example, the subject and object, you could have like a different translation. So linguistics could come up and design these rules and constructions, but then, as you can imagine, this was very difficult to maintain. You have to go back and refine when, language is so complex, and you cannot predict all the possibilities and rules that can define a language. So that's why at that time there was a shift from a rule-based system to like data-driven approach, in which you learn from data. If you have a lot of data, you can train the models in the statistical way, which was the first type of machine translation. And nowadays is like using neural machine translation, which are based on neural networks. And of course, during the time, many different approaches have appeared, from like recurrent neural network up to now that we have transformer-based neural machine translation. So one problem with the a data-driven approach is the data, like the data limits this approach. And nowadays we have this gap between so-called high resource and low resource languages, where the high resource languages are languages like English that have like a wide presence on the internet. You have enough data to train the models, but then in the tail of this graph, you can see that there are languages that have really low resource, which is the case of many African languages. And how can we train the models to also, fill this gap between the higher resource languages, like the problem that we are dealing in this area of research. So you can expect many of the tools that we have now in the market on translation, and you see in terms of quality in terms of translation, translating like African languages or low-resource languages are still poor, and also the coverage of these systems are also poor. So I would say less than 200 languages are covered by these existing tools, which is very low compared to like living languages in the world, like more than 7,000. And that's why we have like nowadays a very active research the community which is trying to tackle this problem. And for example, in the African context, many researchers come to tackle this problem. And what, as you can see in this map, the heat map means that the countries that we mostly have contributed to research on the machine translation research. So, but even if we see on this, if you look at this context of African continent, we can see that there is also more underrepresented language, which is the case of, like, for example, Lusophoning countries, which, if you see in this map, they are less contributed to the body of knowledge, and that's why actually this was the motivation for me PhD, and my focus was contributing with one of the languages spoken in these Lusophone countries, in this case Mozambique, which is the language called Emakhuwa. It's the most spoken language in Mozambique. It has more than 7 million speakers. It's, of course, a Bantu language, has like tonal characteristics. It's a agglutinative language and also gender neutral and use like Latin script. So in this map here, I'm just showing the different variant of the language, where the most like the standardized variant for at least for writing is the greenish here in the center of the map. So this is one that is considered the standard for all the variants that we have for Emakhuwa. So the Emakhuwa is a low resource language which falls on this category, the category 1 of Joshi taxonomy, which means that the language have some unlabeled data. However, collecting data is very challenging, and this was one of the difficult part of my research. We didn't have like a lot of data, so I had to collect and also translate or create like bilingual data for Emakhuwa and Portuguese. And then so I did a lot of data collection, and both for training machine translation system, also for testing them. So this is me with the translator in Mozambique doing this data collection in Mozambique. And from this data collection process, I've learned a lot. One of the things is translating from like higher resource language into low resource language. It's complex. Like a translation level is very complex. And one of the problem is low resource language lacks vocabulary coverage. So if we see in the slide words like video, radio, television, so this the words are coming from Portuguese into like high resource language into low resource language. So how can you translate that into language that doesn't have those vocabulary? So that was most of our discussion during the data collection or translation process. And then one thing that I've learned from there is that the translator usually resort on lexical borrowing or code switching. So lexical borrowing or loanwords is something that we can see here below in this slide, where you borrow a word from a high resource language into low resource language. So you see words like internet. It's adapted to fit like the language as internety, something like that. So you adapt that borrowed word into target language. And we have so many examples here. But then the problem is the adaptation process is not like straightforward. It usually depends on like the preference of the translator. So you could have so different spelling for the same word. Like that's something that we saw on the existing text data, and then the fact that of most of African languages, and specifically this language pair that I was working on, is morphological complex. Like Emakhuwa is a agglutinative language. You need to, when you're adapting these words into like target language, you need to take into account like the pluralization rules, how to conjugate appropriately, also all the adaptation to fit the language, the recipient language. So as you can see here in this slide, you can see the word radio has been adapted into so many forms, but all of them are arguably correct because there is no clear standardization or spelling standards on the language. But then if you give like a text with one of these spelling option, the person will accept that spelling. But then this is very well done by humans. But when it comes of machine translation system, they kind of have difficulty of producing acceptable adaptation. So if you see in this slide the word computer, a human translation managed to adapt to fit like the language rules, but the computer and the empty system here, he did it. He did a poor translation. For example, the word computer, he started with the letter C, which has a different sound in Emakhuwa. And actually, this is a violation of the language rule. So if you go to what is happening now, we do a lot of data, synthetic data generation with machine translation. And imagine that this machine translation system are generating new words that actually not natural. They're actually contaminating the existing text corpora. And then like in the long run, this is very risky. That's why we ask ourselves, how can we guide machine translation to perform more accurate and appropriate loanword adaptation in low resource settings? And through the literature, we found this concept, which is constrained narrow machine translation, which is the concept of guiding the generation of the translation output based on particular constraint. To give an example, let's see this sentence: spend the whole night chasing the path. So if you want to translate this sentence, depending on the domain that you're trying to translate, it could have like a different translation. If you're trying to translate like in a biological domain, it would be like actual bug, but in like software engineering is a different thing. So that's the whole point of constrained neural machine translation, where you try to guide the translation output based on like a particular terminology of that domain, for example. So many approaches or strategies exist for doing that, like data augmentation, which we actually use in this particular research, and I will explain later. But then Nowadays, there is a very interesting trend, which is using LLMs, following, and of course, these models are being trained to like set certain checkpoint, and then you can use RAG to give them more information. And this approach, this new approach, or this new trend, to me, resembles what we have in the past, like the early machine translation system, where we have linguists like providing the rules, but then they didn't have the second part where is the data. So we know that low resource languages, like realistically talking, it will be very difficult to cope with the high resource language because of the limitation in terms of data. But how about we also leverage from the existing information, like linguistic information, like dictionary, grammar book, etc., to also help to produce better translation. That was my hypothesis. And then just to give more explanation of this, let's suppose that we have a machine translation system that has been trained on a typical way, where you have feed the system with parallel data, and then now you ask to translate, for example, this sentence, and then you're likely going to have like a wrong output, as I explained in my previous slide. And then with the approach that suggesting this study is that we can provide some more signals for the model learn how to incorporate appropriate translation, the appropriate terminology in the target output. So we applied these or explored two architectures which are usually used for machine translation. One is the encoder-decoder, which is this first option, in which what we did is augmenting the data with this scheme that we can see here. We have the word, the potential long word, and how can you adapt. So we're hoping that the model will learn how to copy that was possible translation for computer. So we apply this to two multilingual pre-trained models in NLP end-to-end. And then we also experiment on decoder-only architectures, and we have different models, different size, but then they all being trained like with the prompt like this one, where you have the fraction of translation plus the guide on how to adapt those long words. So for training the models, we use the data set that we have collected. During the process of collecting data, we ask the translator to provide the mappings of like donor recipient, like Emakhuwa Portuguese. When they are translating, if they feel like they result on long word adaptation, they had to provide that, and then we had those long word annotation. But since our data is not only this data set that we collect manually, we also got some data from the internet, but mostly religious, text, and also other domains. So we also weekly annotated this data using a model fine-tuned from GPT-4o Mini. So what we did was fine-tune this model on the task like this one, where we provide source sentence, target sentence, and the model would output a mapping of donor recipient relationship. So this model basically we train on the data sets that we had, the manual annotations, and then we evaluated, and when we got like 90% of accuracy, we got the confidence to use this model to annotate the remaining part of the data which didn't have an annotation for long words. So this was the prompt that we used for training for fine-tuning this model. But then we also evaluate on the FLORES, which is data set that we also construct during the data collection process, and also has like manual long word annotations. And our idea was first evaluate if the machine translation in terms of quality gets better or deteriorate. And for that, we use automatic evaluation like Blue, CHRF, and AfriComment. But we also evaluate using two humans independent annotators, which basically evaluate each translation output on a rate of 0 to 100. And then, yeah, we compute like the agreement between them, which was moderate. And we also evaluate like at what level of accuracy of the output and of the loanwords in the output generated. So in terms of the training process, we have two setups. The first setup, we train like the typical way of fine-tuning machine translation systems, which is just providing parallel data, and then which we call without constraint. And then we have the with constraints, which is basically the approach that we are suggesting. Plus, basically, we have like a mixed setup where we provide the standard inputs, plus we also provide the augmented input. It's like a bit of data augmentation with constraint mechanism. And then the model was a way of training by directional way, and for the LLMs, we do some parameter efficient methods with LoRa, and then we explore different sizes of models. And this is the results that we got. In the top, we have the baseline where, as I mentioned, like the typical way of fine-tuning using parallel data. And then in the bottom, we have our method, where we can see clearly in all the metrics that we evaluate, we got better results, significant better results. And we also noticed that LLMs tend to get more improvements as compared to like the baseline. They just better doing the task of adapting loanwords. And then as expected, these and the gains are more significant or greater when you translating from high resource into low resource, like from Portuguese into Emakhuwa, which was what we expected, given the fact this is the direction that we mostly have those problems with loanword adaptations. And we also evaluate the robustness of the model if you just provide a single, like the standard in the model trained with loanword constraint, you just provide a typical or standard input and see whether the model will deteriorate in terms of performance. And then we didn't find any deterioration. In fact, some cases even got better than the baseline. So the model was robust and stable. And then with the humans evaluation, you can see that human preferred models that were trained using our approach. As you can see here by the blue-violet plots, where they are at the top, which corresponded the models that ranked higher in the humans evaluation in humans evaluation. So what is it? What does it mean in practical sense? Let's say this is the sentence that you want to translate from Portuguese into Emakhuwa. So this sentence, the input sentence here is from the plane where we saw many hyenas and wild boars. And when we use our baseline system, like typical machine translation fine-tuning approach, the translation is completely wrong, which says, then we saw a lion cub and a rabbit cub, which is completely different than distance in terms of meaning, and the source sentence, even with the reference which is here. And with our approach, we managed to get more closer translation, where we have also or proper long word in the target sentence. But then we also have some minor mistranslations here. I mean, some minor errors, like hyena and wild boars were translated like we're just code mixes. So it's just it's doing just code mixing, keeping as it is in the source sentence. So, but then the results are even better than the baseline. And we keep asking ourselves, how can we improve these results, especially on this case where we have native words that have been wrongly translated. So we ask ourselves this question: what are the benefits that bilingual dictionary integration provides overall long word constraints? And then from there, what we did was just expanding our prompt that we had in the beginning by adding the dictionary information, as you can see here. And this dictionary information, basically, we got it from three steps process, where we first collect different manual, physical dictionary. We scan them, and then we find a way of creating, having each independent entry of dictionary using OCR, and then like keeping them as JSON file. Then for each sentence pair on the training and test that we did matching, or like finding the words in the sentence that matches with the dictionary entries. So to do that, we use fuzzy matching, and we just keep sentences or I mean, matching that score over 85 in terms of matching the score. And then we basically, for each matching on the dictionary and long words that we have, we construct a prompt, adjust the prompt on something like this. And then our model and to be even a bit of better, especially for Llama model. And this basically shows that we can improve those models in terms of how accurate on predicting the words or the outputs. So in practical sense, going back to that example, after training the model with that approach, we have even better results. Here you can see that the translation is like from the plane, we saw hyena and wild boar. Of course, the translation is not 100% correct, but then because there is a missing word, which is many. So it doesn't say it's so many, but it says it's so hyenas and wild boars. So compared to the baseline, also it's completely like this approach provides more closer outputs to the reference. So in like an actual production scenario, what we envision is something like this. Instead of you having like translation system where you have only one box to input your sentence and you get your translation, you could have like an option to decide how to guide some terminology that you have on the input sentence. So this comes to the conclusion where basically, if I have to summarize what this paper is we investigate the impact of binding empty systems with loanwords and dictionary constraint in loanwords settings, but we focus on the amount of Portuguese language pair. And then we show that this method basically end up enhancing translation quality, which is reflected by the different evaluation metrics that we have. And we have evidence that this is equally positive in multilingual machine translation models or or LLMs. And thank you, everyone. Happy to get your questions.
I have a question.
Yeah.
Steph.
Yeah, please go ahead.
Yeah. Thank you, Mr. Adler. This is an amazing presentation. Very wonderful and very insightful. My questions are two. One, Emakhuwa language is a low-resource language, right? Now, considering the models that you've experimented, was Emakhuwa pre-trained with those models? If yes, then why do we have to integrate or support the training process with the loanwords and then the dictionary? That is number one. Number two, in your experiments, did you ever look at the computational resources needed? Because when you do the basic translation training using the sentence PS corpus, straightforward. But here you are bringing in additional additional set of data set to complement the training process. Does that in any way impact on the computational requirement during the training, or compared to when you do the straightforward kind of training without those constraints? So those are the two questions.
This question is on the
Whether
if they been trained on the market. Yeah. So none of those models have been trained on. Yeah. All right. So for the second question, okay, I'm sharing here like the output of research, but I have tried different things, and in terms of computational requirements, this process is way less computational requirement because you only do like pre-processing stuff, like just doing data augmentation at the south sentence without having to impact in the architectural part, or you have to like overhead or something like that. And I actually did that, which were more computational requiring, but the results seems to be even better doing this way. Yeah.
Okay, thank you.
Thank you. Millicent, you have a question in the chat. Do you want to unmute and ask it? Okay, she's asked me to ask a question. So she says, excellent presentation, Felermino. Your method integrates loanword mappings for Emakhuwa. How well can this approach generalize to other low-resource African languages with different borrowing patterns or morphology?
That's a good question. In fact, now I'm trying to expand this like a feature as a feature of work. I'm trying to expand this method to other languages. I presume that my hypothesis is that yes, this can be expanded to other languages, and yeah, but I haven't actually did an experiment. That's what I have for like future works to.
Guillermo, I can see your hand raised. Please go ahead.
Yeah, thanks, Steph. Millicent already asked my question on scalability to other low-resource African languages. But Felermino, great presentation. Thanks. Before that, my question was like, one, how expensive is it to, when you mention this constraint-driven training and inference, if I want to do it for a new language, what is that, additional resource I need or computing I need to include that? Having said that, what's like the baseline with those models out there? How is the gap between low resource language and higher ones narrowing down in machine translation. Do you see we need to have such approach going forward with the latest technologies out there?
So I haven't. The second question, you can come after to explain better. I don't think I really understand well. But for the first question, in terms of like how expensive is this approach, I feel like this is one of the less expensive, because what was the assumption? My research is how can we use like existing resources like dictionaries, which are more available on these low resource languages than like parallel data. So this is one. But then for long words, I feel like this is the most expensive part of this resource, because you need to go and collect those long word mappings between source and target sentence. But there was this approach that I basically use, which we can leverage to as a starter, right? So you can basically use this LLM like GPT and train on like a prompt like this one, where I provide a source sentence, target sentence, and in this case I just have like less than 1,000 examples, and then the model managed to generalize, and then I use that model to basically annotate the remaining part of the model, that of the data set that didn't have like manual long words annotations. So yeah, I feel like this is one of the less expensive way of doing data augmentation, and plus you are bringing the linguistic parts, like the actual rules of the language to help in the generating good translations. If I can respond the second question, and you correct me if I didn't understand well. I feel like there is still a huge gap between high resource language and low resource language, and one of the problem is that to cope with high resource language depends on heavily having data, which is almost unrealistic that we're going to have in like very short time, short period. So, but then with the LLMs now, I feel like these LLM era are helping to getting better models. I've seen that some of the models are kind of getting acceptable translations. Recently, yes. I don't know if that was the question.
It was. Thanks for me now. Because I was wondering, with these new technologies, I could see you use GPT for mini as a weak annotation. So every time we have a challenge in low resource setting, always how can we close that data gap is a key challenge. But I feel like it's getting better and better. This is an evidence from your slide to use those as weak labels when you don't have enough loan words and all that. But you correctly addressed my question, Santi.
Steph?
Great. If anyone else has a question, feel free to just unmute yourselves and ask Felermino.
Yes.
Go ahead, Malik.
Yes, I quite understand the principle behind your training stuff. So you're doing an augmentation, right? Just to ensure you have a robust model. So part of those augmentation were basically these long words that were mapped, Portuguese, and then the Emakhuwa, and then the other one, the dictionary also. Now the dictionary part of it, that as part of it was augmentation. Were they manually annotated, or I think there is a place where you pinpoint a fuzzy logic or fuzzy algorithm.
Fuzzy.
Yeah, fuzzy, yeah. So how do you do that comparison between the ground truth dictionaries and then how is that algorithm? That is number one question. Number two question, I always have multiple questions.
Yeah, that's good.
So number two question now is that augmentation using some manually or existing data set to augment with what you have. Have you thought of doing the other way around, like the back translation? Have you done the comparison where you allow the model to do the translation back, and then you bring both the translated and the back original data set and see how the outcome is? So those are the two questions.
Thank you. Very good questions. So the first question, in terms of how I like the fuzzy matching. Yes. So if we see this slide, what like in terms of implementation, I didn't want to go like in deeper because that would be making the presentation.
For example, you have a Emakhuwa dictionary. How do you do that mapping and get this code to Portuguese?
So you have the word hyenas. So you have different words on that source sentence. So we only have the Portuguese to Emakhuwa dictionary. So that's why even the slides from here to the end is just Portuguese Emakhuwa side. And you have each of the words on this sentence. So you compare, or not only the word, even you go from like 20 grams, 1 word, up to like 5 grams. Yes. And then we compare that with the, if they match with the dictionary entries. But then the comparison in the dictionary entries is based on lexical similarity. Yeah, so based on the lexical similarity, which is basically what we have on that fuzzy matching threshold. So if the threshold is higher, then of the similarity is higher than 85,
yeah.
So we say this might be a good match. But what I'm saying here is that some of these matches could be wrong, like could be like a noisy data. Yeah, but we did some experiment on how this noisy data influence on the quality of the translation, and that's why we came up with that threshold of 85. So below that, you might mostly got some noise, and then the model. So that's what we did. And for back translation, actually we came up with this idea after performing the back translation. And from my experience, I didn't really like the back translation. Yeah, so I feel like the back translation was risky, like creating noisy data as well. Yeah, but because these systems were not pre-trained on Emakhuwa, was creating very noisy data. That's why I decided to ground the augmentation on like linguistic and actual linguistic information, external linguistic information to guide the translation.
That makes a lot of sense. Given the fact that the model were not pre-trained with Emakhuwa, yes, back translation would make no sense.
Yeah.
Any additional questions from our remote joiners? Great. Felermino, if you could share any relevant links to your papers in the chat, that would be great. Or anywhere we can find some of your work online. And if that is all, I think we can all get 10 minutes back. Thank you everybody for joining. We will be posting the recording of this talk on our website in the coming week. Have a good afternoon.
Thank you. Thank
you, everyone.
You cannot take a part and sleep well.